In this video, I want to have a look at what's called the least squares line of best fit. So in one of our earlier videos, we looked at drawing a line of best fit by eye, but we discovered that it wasn't very accurate. So what we're going to do in this video is we're going to find the equation of the least squares line of best fit, which is sometimes also called the least squares regression line. And we're going to use formulas that are on your formula sheet. So if we just have a look at the first bit on your formula sheet, we've got that the least squares line of best fit is y equals the gradient times x plus the y-intercept, which is exactly what we've been using when we've been writing equations of straight lines, but we've been writing it as y equals mx plus b, where m is your gradient and b is your y-intercept. So it's exactly the same thing we've already been using, but written a little bit differently. But what we need to know is how to figure out what the gradient and the y-intercept are. So we're given two more formulas as well. The first one is this. It says the gradient is equal to r, which you will hopefully remember is the correlation coefficient, times the standard deviation of the y-scores divided by the standard deviation of the x-scores. So we'll have to figure all three of those things out. Then to find the y-intercept, it's going to be that y with the bar across the top of it means the mean of the y-scores. So the mean of the y-scores minus the gradient, which we just figured out, times the mean of the x-scores. So we're going to have to figure out 5 things. We're going to need to find the correlation coefficient, the standard deviation of both the x and y scores, and this little symbol here, that's what the standard deviation looks like on your calculator. So they're the symbols you're looking for. And we need to find the mean of the x and y scores as well, and then we can plug it all into there. So let's have a look at an example. So we've got 12 students measured the height of their belly buttons and the length of their right foot, and then we've got all the numbers in the table there. So this example has broken each piece that we need to find down and then asks us to find the equation at the end. So the first one asks us to find the correlation coefficient, correct to 3 decimal places, and we're going to do that on our calculators. So like we did in one of our earlier videos, we need to put it in stats mode first. So mode 1, 1, and then we need to enter all our data in pairs. We're going to go 103, 25, m plus, and do that for all of them. Okay, so like we did before as well, we've got 12 pieces of information entered in there and we needed 12 of them, so we know we've entered it in hopefully right. Alright, so now to find the correlation coefficient, it's going to be alpha, and then we want that little r that's there above the division key. So we're going to go alpha and then your division key. To get that r, hit equals, and we'll end up with, to 3 decimal places, 0.540. So r is equal to 0.540. So that's our correlation coefficient. Now we need to find the mean and standard deviation of both the belly button heights and the foot lengths. So we've already got all the information in our calculator. We don't need to re-enter anything, and we need to go through and find those things. So the belly button is going to be our x's, and our foot length is going to be our y's. On your calculator, above the 4 key, you've got the symbol, the x with the bar across it, that's the mean of your x scores. And above the 6, you've got a sigma and an x, that's the standard deviation of your x scores. So we're going to go alpha for equals to get the mean. So we'll have the mean 101.833, and the standard deviation of the x scores. So then we'll go alpha 6 equals, and we'll end up with 6.216 to 3 decimal places. So to do the y's then, so the mean of the y scores, we're going to go alpha, and then that's written above the 7 key. You've got a little y with the bar above it. So that'll come out to be 25.583. And the standard deviation of the y scores, so alpha, and then the standard deviation is above your 9 key. So you've got standard deviation y, so we'll press 9 equals. We'll end up with 2.957 once we round up to 3 decimal places. So 2.957. Okay, so we found all 5 pieces of information we needed. Now we need to put them into our formulas. So we want to eventually get to this formula up the top, but to be able to do that, we need to figure out the gradient and the y-intercept first. So let's start with the gradient. So gradient is equal to the correlation coefficient, which was that 0.540, times the standard deviation of the y-scores, which was this one down here, divided by the standard deviation of the x-scores. And then we can pop that in our calculator. And we'll end up with 0.257, sorry. So that's our gradient. Now we need our y-intercept. So move that up a little bit. Your y-intercept is the mean of the y-scores. Mean of the y-scores, which is that's your standard deviation, 25.583, which is this one here, minus the gradient, which we just figured out was 0.257, times the mean of the x scores, which was 101.833. So we're going to pop that in your calculator now. And we'll end up with, if we round that to 3 decimal places as well, minus 0.588. Alright, so we know our gradient and our y-intercept. Now we're going to pop it into this equation that's right up the top. So we'll end up with y is equal to the gradient, which was 0.257 x, because it's times x, and then plus your y-intercept. But your y-intercept was minus 0.588, so we're going to go minus 0.588. So that there is the equation of the least squares line of best fit.